Respected speaker, principals, teachers, a very warm good morning and welcome to the fourth session on Spot Prelim Virtuals. Before we move on to the introduction, as in the previous sessions, a quick set of guidelines. This session will last for around 1 to 1.5 hours. And yes, it is a topic where you can have a gazillion of doubts, but please make sure that you type in your questions in the chat box with your name. We will have a Q&A session towards the end. Also, kindly refrain from posting the same question repeatedly in the chat box. And also a special announcement for the students. Kindly note that the Spot 100 finals that was scheduled for the 24th of February has been postponed to the 5th of March. You will receive notification. Kindly check your mail and also visit our website for further details. Now moving on to the topic, astronomy from space. Many of us, if not everyone, is amazed by the night sky. And thousands of years ago, ancient humans would have likely gazed up in wonderment and marveled at the bright moon, the fiery sun, and the star-filled sky. The astronomical backdrop then wouldn't have been much different from what we see now, but how we interact with it is assuredly very, very different. These ancient humans meticulously observed, studied, noted what they saw, and this later grew out to be one of the oldest sciences, astronomy. In simple terms, it is the study of everything in the universe that is beyond the Earth's atmosphere, the study of stars, planets, and space. It is a discipline that opens our eyes and gives context to our place in the universe, and that can reshape how we see the world. And as the world progresses, and with the discoveries of the connection between the basic elements that make up the stars and what we have in the human body has further deepened the bond that we share between the humans and the cosmos. Astronomy deals with many unanswered mysteries, and perhaps it is this mind-boggling, mysterious nature of astronomy that makes it truly special. And today, as our speaker, we have a stalwart in the field of astronomy. I am honored to introduce you to our chairman, Padma Bhushan, Dr. G. Madhavan Nair. Dr. Nair was the creative mastermind behind Chandrayaan-1, India's iconic moon mission. During his tenure as the chairman of ISRO, he contributed towards the charting of roadmaps for future development of ISRO's activities. He has accomplished 27 successful space missions. Few of the significant missions include Indian Satellite INSAT 3E4A4B, Polar Satellite Launch Vehicle, PSLV, C5, C6, C7, C8, C9, 10, 11, 12, and 14, Geosynchronous Launch Vehicle, GSLV, F01 and F04, and most significantly, the moon mission, Chandrayaan-1. Sir, we are elated to have you here with us today. May I now welcome Mrs. Suchitra Shaijan, the Executive Director, Vssf, to share some insights for today's session. Ma'am, please.
Thank you so much, and namaste. So once again, it's indeed, as mentioned by Ms. Shilpa, it's indeed a delight to always host you and hear you in about a branch of science which is extremely mystic and extremely curious for learners. So today we are going to talk about astronomy from space, and more importantly, I would like to address to the learners that, sir, it is sir's mastermind along with Dr. Kalam sir that, we are able to connect today through a virtual platform through the Vikram Sarabhai Science Foundation portals. In fact, from the very inception onwards, this has been dreamt by these people to make science a reality for learners. And Dr. Madhavan Nair sir has been a person who has traveled along with the evolution of, let us say, Indian space program. From the very beginning onwards, he was able to evolve the ways and process by which Indian space program has been is there today. And definitely there are so much of opportunities India has in space, and that is only possible not through us, and it's only possible through learners like you. And precisely that is why we try to engage you through these kind of topics which would inspire learners in future. And all of us, including me, always find space a very, very curious area or a branch of science. And we always get surprised as to how space functions, or how things function in space. And definitely this branch of science has a lot of potential in future, because not only as a branch of space science, but there are so many allied branches which are associated with space science. So today's session, our honorable speaker Madhavan Nair sir would engage you about India's achievements in space, and space as a domain of exploration, and space, the opportunities in space. Probably sir would speak to you for 20 minutes max, and then we would take up questions as our MC has already mentioned. We would like to clear your doubts, which is more primary, because there are lots of things which you get to read. But it is most important to hear from those people who has really worked in these domains. So primarily we would engage around 10 to 12 questions through the process. But as your MC already shared with you, try to make sure that you post only once, and don't create disturbance. Some of you are asking, please stop the chat also, which we are not in agreement to that, because we want to hear you out. But my belief is that you would very responsibly handle the situation. So we are not muting the chat or anything of that sort. We want to hear you out. At the same time, I would request you to be as sensible as possible in your interactions, in your questions, in your mode of dealing the session. So once again, as already mentioned, it's a delight, sir, to have you, and we are eagerly waiting to hear you for the next 15-20 minutes. So most humbly, with utmost delight, I would request sir to take over the session and enlighten these learners in this branch of science. Over to you, sir.
Thank you, Sujitra, for the nice words of introduction, and also explaining the background of Vssf activities. I'm extremely happy to note that VSS is active even in these COVID days, and has already conducted a few sessions interacting with the leading people in various walks of life with their achievements and their experience. Today, I'm happy to be with you and then share some of my thoughts about the space research on this occasion. Also, I would like to send my greetings to Srimati Dr. Indira Rajan for the founder of this movement, and I hope she is also here to participate in this session. Well, the COVID times has been extremely difficult. It has caught the entire humanity without any notice, and it has affected almost everybody in every nook and corner of the world. But the beauty of this is that the global scientific community has risen to the equation, and especially Indian scientific community has come forward and found a vaccine within the shortest possible time, which was able to contain this spread of this COVID pandemic to a great extent. That shows that how today's technology has advanced, how collective work can be implemented through the electronic media and so on, and how manufacturing plants can be set up at short notice with modern technology. This all shows that how the science and technology is playing a key role in the society today. India definitely can be proud of this recent development of producing vaccine and virtually become the center for COVID vaccine for the entire globe, so to say. We were able to produce much more than what all other countries put together. Not only we are meeting our requirement, but also we are really meeting the requirements of our neighboring countries as well. That goes to the credit of the scientific community in this country. And I'm sure this is what needs to be nurtured in the years to come. All of you know that after independence, India has seen tremendous progress in several walks of life. Notably in the science and technology area, the far-sighted vision of the administrators have helped us to establish the education institutions of world-class research facilities, especially in the field of agriculture, atomic energy, space, and so on. This has helped us to be in the forefront of nations as far as the technology is concerned. You are aware that today we are producing not only food grain sufficient for us, but also able to export some part of it. Compared to what there was in the mid-60s, people were starving. Hardly 40% of the food grains were produced here. Thanks to the green revolution brought in by Dr. Swaminathan and his team, that we were able to achieve this poverty eradication scheme in the country. But later you have seen that parallelly we were working on atomic program. Today we have deciphered the mysteries of atom, thanks to Homi Bhabha and his team. And today we know how to split the atom, generate energy from that, and then use it for the benefit of the humankind, whether it is the field of agriculture, medicine, or the food preservation, and above all, to create energy for peaceful beings, as well as for our defense purposes, the atomic weapon. Now, look at the space. Again, the far-sighted vision of persons like Dr. Sarabhai has helped us to take a lead. We were late starters as far as the space research is concerned, compared to the other developed nations. We have about 20 years behind them to start with. But today, we are in par with the global community as far as the space technology is concerned. We have mastered the rocketry, whether it is solid rockets, liquid rockets, cryogenic rockets, or even ion propulsion, which can be used for long duration flights in space and so on. So we are masters in that. Similarly, we have built satellites for various applications, Earth observing satellites, communication satellites, scientific research, and traveling to Moon, Mars, etc. And above all, we were the first country to put this to use to improve the quality of life of the common man. To start with, we have used it for resource survey in the country to assess the water resource, mineral resource, and the agriculture, forestry, and so on. This became handy for not only for the planners, but also for the agriculturists as well. Then about the communication, we started connecting the metros with high-speed lines. But later, today, we are enjoying the benefit of receiving the hundreds of television signals on the rooftop using what is called DTH. This DTH is not only enabling us to do the entertainment, but also today it has become handy for the tele-education programs. And not only that, the business houses and the banks are connected to the satellites so that they can use this as a seamless service to the people. The most important aspect of today's technological application is the warning which we are issuing to the flood zones or the cyclone affected zones and so on. The satellite images provide the picture of the cloud temperature, moisture content, and all these parameters. So we can predict where the heavy downpour is going to take place, at least about 24 hours in advance. Similarly, the cyclones, normally they get formed in the sea. There itself, we can capture that and track its movement and give a prediction as to where it is going to hit the land mass. So this will help the local authorities to evacuate the people and safeguard the properties so the losses are minimized. So the disaster management system, which is based on the satellite-based observation and satellite communication, has become our mainstay today. Again, the telemedicine. Today, you know that many people hesitate to go to the hospital, but even from the remote mountain areas or islands, people can contact the specialty hospitals and communicate with them, discuss with the doctors, and they get treatment without traveling to the hospitals. The telemedicine also has become a very, very popular scheme in the country today, especially in the days of COVID. So thus, we have really achieved several things which will benefit the common man, and it has gone towards improving the quality of life of the people in the country. Now let us, while completing all these things, we have not forgotten. Mankind is always inquisitive about how and why of our existence. It starts with the universe, 13.5 billion years back, with the Big Bang. From nothing, the universe came into existence. Initially, it was only energy. From the energy, the particles evolved. The particles congregated and became elements. Elements consolidated and became the stars. And from the stars, of course, the planets and so on. That chain is known until now. But what is in store for us for the future is really a big question mark. While saying this, well, still there is a big question open before us. From where, from or how, out of nothing, this huge, you cannot predict in terms of numbers, huge quantity of energy has come out. That's something which is mysterious and people are trying to track back to T0, which I think we are not able to, the humankind has not able to achieve so far. The collider, which is there in Geneva, the CERN, that collider is able to give some ideas about the subatomic particles and how it got, in fact, that will create, it is given a funny name, the God's particle. All of us say that, God has created the universe. But it may be so, but where is a God? What is a God? Where is it? How is it? So these are the questions open before us. Now, the next big question is, the universe is continuously expanding. We are not able to reach up to the edge of the universe yet. Powerful telescopes are required. From the ground, you have to have huge telescopes, but it is affected by the atmosphere and the observations are not very accurate. So the space-based observation becomes very important. The space station is continuing to do something. And then, of course, the Chandra telescope, which is operated by NASA, is providing valuable data. ISRO also has launched its orbiting astronomical laboratory called AstroSat, which is able to look at the galaxies and the stars at faraway places and try to characterize them. So this, the trying to look outside the universe is very, very important. And while doing so, there are many other studies one can do with respect to our nearby neighbors, like Moon or the Mars or the Venus. Why I'm saying this is, as all of you know, about 4.5 billion years back, a big chunk of Earth got detached, and that has become the Moon, what you call the satellite orbiting around Earth, the natural satellite orbiting around Earth. And there is no atmosphere, there is no weather conditions like what you face in the ground, etc. So if you go there and try to explore what is there on the surface, what is the nature of elements there, what is the type of surface features. So all this will give an idea as to the origin of the Earth and how it evolved and how today it has become a lush green covered planet with a lot of water availability and so on. So this is something which you are trying to do. So as part of this, I'm proud to say that India has done this way back in 2009 the first satellite, artificial satellite, which sent to moon. It has reached the moon. It started mapping the entire surface. We have over 95% of the surface mapped with very precise resolution. The high mounts, the craters, the surface, etc., is detailed. The pictures are taken. Stereoscopic images are being built. The laser images are used for finding the heights and depths and so on. And ultimately, we were the first in the world to announce that there is water on the surface of the moon. Long back itself, people believed that there's no water and there is no life that can exist there and so on. But traces of water there on the surface, right from the equator onwards. But the surprising finding was in the polar region, where sunlight doesn't reach the craters, it is sub-zero temperatures, and there huge blocks of ice are there. So it is believed that while it separated from Earth and moved on to its own orbit, huge quantity of water also was carried in, and that is staying there as ice blocks in the polar region. So this is a great finding. Later, if you are thinking of setting up a colony on the moon, it will become handy. One can definitely tap this. Moreover, the finding of helium deposits on the surface of the moon has been an important activity. There we have mapped the regions where huge deposits of helium is there. Helium is a gas which is evolved from sun, and since it is very light, it is slightly denser than hydrogen, it cannot penetrate the atmosphere and come to the ground. So only way. And if we can bring here, it is going to be of tremendous use to the humankind. This is mainly because, the helium-3 is ideal fuel for fusion reaction. So far, we are concentrating on fission reaction. That is, heavy atoms are split, and from there, energy is released. Whereas in the fusion reaction, the light elements are brought together, and they are made to join together to form the heavy elements. So in this process, the heat released is thousands of times more than what you get by splitting the atom. So the fusion reaction, helium-3 is the ideal thing. But to cite an example, if 1 kg of helium-3 is there, that is sufficient to meet the entire energy needs of our country. So that powerful is the helium-3, and we have to see what means we can exploit this, how we can extract, how we can liquefy and bring back to Earth and so on. So this type of exploration is going on. As a follow-on, we wanted to land a rover on the surface of the moon and pick up samples and analyze. But unfortunately, the second mission did not succeed completely. It reached up to about 2 kilometers above the surface of the moon. There something went wrong with the landing device, and the net result is it crash landed on the lunar surface. Soon that will be attended, maybe within a year or so. And that way we will be able to reach there and collect samples as well. Now, not only this, we wanted to have a look at the Mars. So using our limited capability of polar satellite launch vehicle, we have set a satellite, the Mars mission. And then again, we were able to put the satellite around the Mars. But unfortunately, due to the mass constraints, we didn't have enough fuel. So with that, it went into the elliptical orbit, and from there, it has taken pictures of the lunar surface, tried to grab some details about the atmosphere. There's a very thin atmosphere presence in the Mars. It is about 1/6 the density of Earth, but full of carbon dioxide. It is not like Earth where it can sustain life, but but it is believed that about a billion years back, Mars was as green as Earth. How it degraded and became a dead planet now is something which we have to understand, which will help us to see what will happen to Earth in the days to come as well. So that way, the study of the Mars will become important, and we hope we will be able to soon go back to Mars and do all these things. Again, you may ask the question, why we are doing all these things? We have only planet Earth for our survival. God forbid some catastrophe occurs here, what will be the alternate abode for human being? Question can be the nearest moon, but moon is, except for the presence of water, there is no favorable conditions. The temperatures are very extremes in the day and night, and also the atmosphere is virtually not there. So that way it is become very difficult to create a colony there. But in Mars, there is some hope. From carbon dioxide, one can split and get oxygen. That oxygen can be used for the survival of the human being as well as plants as well. And even the temperature can be adjusted in such a way that plants and other things can be cultivated there. And water also is available. So that way Mars may become more attractive. That's why more and more countries are turning towards Mars. So that way, the nearby planets exploration is one thing. Trying to look at the galaxies, its origin, its neighbors, and whether the life exists on other part of the universe. All these are big question marks before us. And that is where the astrophysicists and astrobiologists are struggling to find answers. So this is a very challenging field, an interesting field as well. It may not produce result tomorrow, but in the long run, that is what is going to help the humankind to survive. While doing so, let us look at what India's priorities are. India is concerned, we are lagging behind slightly in the human spaceflight missions. So, but at the same time, we have 2017, we have initiated the human spaceflight program. That has initiated the development of a capsule which can carry 3 astronauts to the space and back. Then from the space, whether we can go to Moon, Mars, etc., will be the next phase of the challenge. Similarly, when we look at the planet Earth, we have the observation capability in the visible band and the ultraviolet band and so on, but they will not penetrate through the clouds. So the radar imaging satellite, recently one was launched, a few of them more will help us in looking through the clouds. So especially during floods and drought-affected regions, etc., can be identified using the resource. Communication becomes a very, very important area. Of course, in most of the cities and towns, the fiber optic communication can reach. But remote areas still will have to depend on the high-speed connectivity, which is to be established through the satellites. So that way, there are so many things yet to be done in the space arena underground as well. We have our competitors. There's mainly US and China, I would say. China has got a conventional rocket, which has got nearly 4 times more powerful capability than India's. US, of course, it was leading, but with the failure of the space shuttle, they got into low F. But now again, it has been revived thanks to SpaceX and some private companies like that. They have developed a capsule which can go back to space and come back safely and land on the ground. And they are providing the transportation for humans and cargo to space station and back. They have also plans to build huge spaceships which can carry something like 100 passengers to the Mars and back. So that's the kind of activities which are happening in other area as well. So if you look at that way, the space is really a very, very challenging field. And India can be proud thanks to the efforts of people like Dr. Sarabhai, Dr. Kalam, Professor Madhavan, Professor Rao. So these leaders have really built up the infrastructure and facilities and provided the enthusiasm to the youngsters who have really become masters in this field. Mind you, all the talents in ISRO today are homegrown. They studied in Indian schools, they studied in Indian colleges, they got the degrees from the Indian universities, and they are the people who are leading the space program in the country today, and they have become the top class experts as in the world. So this shows that if we set our goal very clearly, strive hard to achieve that, definitely success will be ours. So certainly we have demonstrated in the space program through that. For youngsters like you, this is a great opportunity. The world is very wide, whether it is in the genomics or in the biotech or in the electronics or software or metallurgy or any field if you take, and ultimately pure science like astronomy, astrophysics, astrobiology, and things like that. There are very many opportunities awaiting you. It is for you to grab. Only thing is you should look at your resources your liking, your aptitude, and your ability to learn new things and apply them to solve the problem. That is what will bring success to you. Don't go by the stereotype program of becoming a conventional engineer or a conventional doctor and so on through our current education system. Of course, we are trying to bring reforms in the education system, but it will take time. But at the same time, pursuing the line where you have a passion, that is very, very important. And hard work, there is no substitute. Then success will be yours. Thank you.
Thank you so much, sir, for your valuable guidance to the learners. Primarily, you were talking about indigenous learned scientists in the country, and they learned in Indian schools. They had Indian experience. They experienced India, and they made a lot of change in Indian space program. But could you throw some light on what are the challenges we had in our initial phase of Indian space program before we move into the Q&A? What challenges India had in setting up an infrastructure like this?
Well, I think we were in a very handicapped situation as far as the space research is concerned. When we started, we did not have any knowledge in this field. Initially, the foreign countries like Russia, Europe, or America, they join hands with us, but they will bring their own subsystems, hardware, rockets, etc. here and do the launching. So virtually, we had to start learning everything from scratch. Now, look at the rocket technology itself. Of course, in the Tipu Sultan's time, some primitive form of rocket has been made and was used as a weapon against the British Army. It was around 270 years back. But at the same time, when we started work, we did not know ABC of the rocket. We had to make the propellants and make them burn in a controlled way. Then we had to make the materials which can withstand high pressure and high temperatures and so on. So right from the raw materials onwards, we had to start the work. Then again, evolving designs, sophisticated designs, where you had to guide and navigate this rocket to the precise orbit, accurate navigation system. Of course, the ancient seafaring nation, they use the sextants. But in place of that, today gyroscopes and accelerometers are the mainstay. This technology was developed in the V2 rocket time by the Germans. But again, because of the potential military application, they will not give us. But our scientists here, they started from scratch. They started making use of the spinning wheels, age-old proven technology for initial reference. But from there, we have come a long way. Today, we have gyroscopes which work based on lasers. Two wing lasers going in opposite direction, their interference the pattern will change depending on the angular rays which is applied to it. And that is being detected and used. This is very, very precise. There is no moving parts. Life is almost infinite and accuracy also is fantastic. Similarly, in accelerometer also, we use some quartz crystals and things like that. So right from the concept, the material, the fabrication, when you talk about the fabrication of these laser devices or the accelerometer, etc., we require few micron tolerance. The machines required for that have to be developed. So like that, we had to really go through the mill. I don't think any other country has such a disadvantage as India in terms of learning this technology. Today, you take even in automobiles or refrigerator or air conditioner, everything is coming from outside. There's no Indian technology. Mainly because they were commercially available. Other companies wanted to exploit commercially. But ISRO is concerned, we were put in a very embarrassing situation of the embargoes. They didn't want to give us technology, any technical details, any materials, or any help. So this has become a real trigger for the Indian use. They took it as a challenge. They worked day and night to realize this thing. Of course, in this process, we have come across failures. Dr. Kalam and myself, when we were making the first satellite launch vehicle, SLV-3, the first mission failed. But we took an oath saying that within a year, we are going to come back. We did so. We tried to identify the reason, tried to make the corrections and get back without losing heart. And within a year, definitely we showed to the world that we can launch our satellites. Similarly, in the first PSLV launch, I have faced a failure. That turned out to be mainly because of an error in implementing a software code in the computer. A very silly error if you look back. But at the same time, it was a big lesson for us to learn about the software quality control, how to validate them, how to simulate them on the ground, and so on. So it was a big learning ground. So the failures, quite often, they teach us much more than a success. So that way, but at the same time, we should not lose heart at such failures. So this is the kind of mode in which we have worked. But as I told earlier, it is almost round-the-clock work of thousands of people, and synthesizing the effort has been a very, very major challenge. So we have done so, and ISRO is the finest example of a teamwork of that kind. Thank you.
Thank you so much, sir. I'm pretty sure that all the children, all the students, and even the teachers, they are hearing you explain how the growth of ISRO from how it was and to where we are right now. It was truly motivating, sir. And as you can see on the screen itself, they have a lot of doubts. So to the children, to the students, I'll be calling out the names and I'll ask you to unmute. So you will have to say your name, your class and school, also the state from which you are from. For the first question, Adit G.
My name is Talish. I'm from Delhi. My class is 7D.
Audio is not clear.
I'm saying that my name is Talish Singh. I'm from Kothari International School. I live in Delhi. My question was that it is not related to the astronomy, but it is related that when that on 5th March there are my finals. So how will I do the VSS spot? I had this question. It is not related to the astronomy, but I wanted to ask because on March there is my finals.
Talish, your questions regarding your exams will be taken up at the end. We are currently having questions that are related to the topic, and Adit G, you have been asked to unmute. You can unmute now.
Yes, ma'am. Sir, my doubt is, how did people measure the speed of light without using the necessary instruments?
Well, I think the instruments get developed over time. But initially, of course, when you want to see the speed of light, you have to really look at, probably the interference patterns which emerge when light beams are made to collide in opposite directions. And from there, trying to look at, give a rotation to the platform and so on. So it's a very elementary way of optical instruments being used. But today, of course, the stars and other sources, they become the accurate, of course, once you know their location and from the time taken for the emissions to reach from there to the ground, even from the sun, they become a good reference for observing the speed of light.
Thank you, sir. Next question, Shaurya Dikshit has a question.
Good morning, sir. My name is Shaurya Dikshit. I am I study in class 7 at Delhi Public School, Firozabad. I live in Uttar Pradesh, and my question is, what is the difference between the PSLV and the GSLV rockets?
Well, initially our requirement was for placing about 1,000 kilogram spacecraft into Earth's orbit. So to meet that objective, the Polar Satellite Launch Vehicle developed in the 90s. To start with, it could take about 800 kilogram into about 500 kilometer orbit. But today it can carry as much as around 1,500 kilogram. But this is not sufficient for meeting some of our heavy payloads for communication purposes, especially for the geostationary orbit. The low Earth orbit is around 500 to 2000 kilometers, whereas geostationary orbit goes up to 36,000 kilometers. To take such a large spacecraft to a longer distance, we require more powerful rocket. So that is where the GSLV came into existence. For example, the PSLV used some 4-stage rockets with a liftoff weight of something like 190 tons. Whereas the GSLV, it is around 360 tons propellant and other hardware put together at liftoff. It has got virtually about 7 stages to start with. And the upper stage is a high efficiently cryogenic stage using liquid oxygen and liquid hydrogen as fuel. So this rocket system is what is developed initially for GSLV. Now the latest GSLV is a very optimum design, so to say. It can carry even double than the first generation GSLV. Today we can take about 4-ton communication satellites to the geostationary orbit, and also something like 10 tons of payload to low Earth orbit. With the 10-ton, it can make even the human capsule, our Gaganyaan capsule will be riding on this GSLV vehicle. So it is based on the capability of the rocket and the type of technology used. It is for PSLV, GSLV generation.
Thank you, sir. Vaishnavi Singh, you can now ask your question. Vaishnavi.
Yes, sir. Yes, sir. Good morning, sir. My name is Vaishnavi Singh. I'm from 7th grade. I study in St. Anandram Jaipuria School, Lucknow, Uttar Pradesh. So my question was that, like, it is said that the sun is made from helium and hydrogen, that are the lightest gas. So I wanted to ask the question that it is said that even when we compile all the 7 planets weight that are in our galaxy, that is Mercury, Jupiter, and all those planets, so they are still like, they hardly make up any part of the sun. So I wanted to ask that despite this, despite the fact that sun is made of the lightest gases, how come the sun be still heavier than all the 7 planets?
Well, basically, you know, the sun is really at a, working with a very, very high pressure. So once you have a high pressure, the density goes up. So that's the reason that within that volume, we have got largest amount of mass. And it is actually the fusion reaction. Hydrogen is joining together and the helium is being provided at the same time releasing energy. That's what is taking place in the sun. So there is the size and the quantity which is contained. It depends on the pressure which works on the surface of the. Most of the other places, virtually it is a vacuum. Whether if you take our distant planets, which is satellites around the Pluto and so on, they are virtually in the gaseous form. They don't get compressed. They're at almost normal pressure.
Okay, so thank you. I've got my question clear.
Thank you, sir. Arush Arora, you can now ask your question.
Oh, yes. Good afternoon, sir. So actually my question is that, sir, actually, yes. So, sir, how do the astronomers accurately determine wobbles in star motion?
Can you repeat?
Yes, sir. Sir, actually, how do the astronomers accurately determine the wobbles in a star's motion?
You are asking about how astronauts determine the star motion, is it?
Yes, sir.
Well, I think again, today our instruments have become very, very powerful. They use telescopes, and then, of course, you know, the recent telescope which is launched by European, it is the reflector is as large as a tennis field. So from there, the energy collected is focused on the detecting device, and there, you know, you can discern even very faint lights emitted by distant stars. So using such telescope is what, of course, if you don't want to look at the nearby stars, you don't need any of these things. You can do a naked eyes. And then there again, these telescopes are mounted on accurate platforms where you can get the orientation in space, which the X, Y, Z direction. And from there, you can directly pinpoint from where the stars is really emitting the light, and also how the stars are moving if you observe over a time. So it is such a observation platform. Of course, one thing is in the space station, there are a number of people who have carried and established those things. Then, as I mentioned earlier, a Chandra telescope, it is a satellite which is orbiting around Earth, but equipped with a huge telescope like this, which can be pointed to any part of the sky. Now, the recent European one also is a similar kind. And our AstroSat also is doing the same thing. So we need a specialized, these days, instead of the conventional instruments, we more depend on the telescopes mounted on accurate platforms.
Next, Akshit Kishore, please ask your question.
Yes. So, good afternoon, sir. I am Akshat Kishore from grade 6 from Lotus Valley International School. So, sir, my question was that if dark matter / energy, it's responsible for driving the universe into, expansion, and it is composed of non-baryonic matter, and still, despite its invisibility, dark matter has been critical to the evolution of our universe and to the emergence of stars, and even to for life itself, it has been critical. And I also know that the dark matter, I'm pretty sure, carries the 5 times the mass of the ordinary matter, and furthermore does not interact with light directly. So to conclude, I just wanted to ask, what is dark matter in depth, and how does it expand the distances between the universe different elements, like a balloon? And also my theory, is it some kind of antimatter or anti-gravity force or something like that?
Well, it's a very, very difficult question to answer. I don't think the entire astronomy community in the globe has found the real answer to it. But at the same time, what we know today is about 5% of the observable objects is that's out of the total mass estimated for the universe. Only 5% are observable by various means, X-rays or gamma rays or the UV and so on. Remaining 95% is unknown. And fortunately, due to indirect observation, these dark matters have been identified. Huge black holes, which comes because of the collapse of the stars, and virtually the star become a point mass, and the gravity becomes almost infinite. So under the gravitational field, almost all the light rays or any other radiation will get bent. So that is a phenomena which you are detecting, and then trying to estimate what is the type of the mass and the gravity involved in that. And maybe to some extent, maybe about 10% of such objects we were able to map. But remaining, we are yet to find out. Again, this entire thing is a delicate balance of the gravitational forces. The known masses, the unknown masses, and the dark energy, all these are there. Now, if you want to explain this, somewhere it becomes the answers are not there. So they substitute with what is called antimatter. And then the question becomes a mirror image of the universe itself may be there. So it's not one universe, there is two universes working in parallel. So many hypotheses are in front of us. It is the astronomers who are searching for answers to this thing. And maybe I will say we have succeeded to hardly about 5% in this job. The remaining still we have to investigate. We have to keep on looking for it.
Thank you, sir. Next, Prishita Samandare can ask the question.
Yes, ma'am. Yes, ma'am. And so my doubt is that it is often said that water was brought to Earth by an asteroid. So is that true?
Well, so far, the findings are that the water was originally itself, it was on the Earth, plenty of water was there to start with. And even today, about 75% of the surface of the Earth is covered with water. So, but at the same time, the moon got detached from the Earth, maybe because of the huge asteroid hitting the Earth in the formative stages. So that is what the moon is having, some remnants of water still there. So due to the asteroid hit, the moon carried water from the Earth. That is what we can believe based on the observations so far.
Thank you, sir. Aravind Sharma, please ask your question.
Yes, ma'am. Sir, my question is that, ma'am, I have two questions. First is that,
Please introduce yourself before you proceed.
yes, ma'am, myself, Arvind Sharma from KPS Nehru Nagar, Bhilai, Chhattisgarh. Ma'am, my question is related to the universe. Ma'am, is antimatter really exist and it is possible to form an anti-universe?
Well, that is a hypothesis, but I don't think there is enough proof to say that. The antimatter exists for a very small time, maybe.
Obediently attend, na babu? किए ना तुम obediently attend.
The antimatter is one hypothesis, anti-universe, both are the hypothesic state, and we do not have any proof as on today. Well, perhaps many phenomena can be explained by using such a fictitious condition. The antimatter is not detectable because its presence is only for femtoseconds or so on, and there's no way, no instrument which can capture this. Only antimatter collides with matter, huge amounts of energy may be released. So that is the only thing which we can look for. But so far, there is no observable proof on that.
Thank you, sir. A note to the students, as soon as you finish asking your question, make sure that you keep your mic on mute. And also, once again, a reminder, please say your class name, school, and state. Next, Achintya Bhatt, please ask your question. Achintya.
Yes, my name is Achintya Bhatt. I am from 6th A. I am in Kerala. My question is, if are neutron stars heavier than black holes? And also, why black holes are forming everywhere in all galaxies?
Well, it's like this, like sun, the stars also were active at some time frame. But as the energy gets exhausted, it collapses and it becomes denser and denser. And finally, it becomes almost virtually a point mass. That is where the black hole or the dark matter comes in. This dark matter, the property is it absorbs almost everything, whether it is radiation or the gravitational field or a material into it. So we cannot really observe this dark material directly. Only by indirect means we can observe this. So this phenomena is taking place. There are millions of stars in our galaxy itself. And so like that, if you start counting, there could be hundreds of billions of stars, and then at least 1% of that, if they are collapsing, you can see the number. It will run into more than few million. So this is what is there, and we are not able to spot all of them. Our effort to really survey the entire sky and then try to spot some objects, it is a laborious one, but it is still continuing.
Thank you, sir. Next question can be by Preet Kaur. Preet Kaur. You can unmute now.
Yes. A very good afternoon, sir. My name is Preet Kaur Gohil, and I am from Gujarat. I study in Countryside International School. My question is, what is supermassive black hole?
I'm not sure about it. So maybe I will check and give you a mail back later.
Okay, sir. So can I ask my next question?
Yeah.
Sir, how speed of light is measured? How did scientists measure the speed of light?
Well, as I mentioned earlier, you have to really calibrate with some standard source. So if you want to do that, the easiest way is make this light beam travel through different media and the different directions, and finally make the interference, measure the interference. From there, we can try to establish what is the speed of light accurately.
Okay, thank you very much, sir.
We'll now have our last question. Sadhnik, you could ask your question, please.
Good afternoon, sir. Sir, I have actually 5 doubts and I study in class 7, DPS GB in Uttar Pradesh. So my first doubt is, why all space agencies are going to Mars? Because in Mars, the atmosphere is not suitable for humans.
Well, as I told you, if you want to look for an alternate habitat, the Mars become near ideal, I would say. Because as I mentioned earlier, there is a carbon dioxide which can be split and we can generate oxygen. Of course, you can split water also and generate hydrogen and oxygen. Hydrogen can be used as a fuel as well. Then the second thing is, the temperature extremes are not that high as in the moon. It is something like plus 150 to minus 60 or so. So within that, you can make air conditioned tents and so on. And then the soil and other things are almost similar to what we see on the Earth. And perhaps the cultivation in greenhouses, etc., may become possible. So that's why we are trying to see whether we can go to Mars in an economical way. Today, the cost-effective solutions are not there, but as the demand goes up, definitely it will come. Like SpaceX carrying about 100 passengers at a time, it becomes almost like an air travel to Mars and back.
So my second question is that, is it true that
Satnik, sorry to interrupt, but due to the limitation of time, we will have to keep your question to just one. With that, we will come to the end of the Q&A session. Sir, I want to thank you once again on behalf of Vssf and all the students here for being here, for spending time with us here and explaining in your way to make these young minds understand. And also one thing that struck me very well was about not going the conventional way, but rather to choose what they are really interested or passionate about. So I really do hope that they will take in your message by heart and strive to make or contribute their bit towards our country and also towards maybe the Indian space program as well. Thank you so much, sir. Once again, thank you so much.
Thank you, Shilpa, for organizing the session. You have very well coordinated. Thank you.
Thank you so much.
Indeed, thank you very much, sir. Before Shilpa, just hold on. Sir, thank you very much for answering all these questions. In fact, there's so much more questions in the chat box. Shilpa, you may please collate it and request to share it with sir, and maybe as time permits, sir would answer it and we will post it back in the chat box. And I'm extremely delighted to see the quality of the questions which children has posted. Though you are in 6th, 7th, 8th grade, your understanding about space science is much above that. So there is a lot of prospects in space science in future. But from sir's interaction, I hope you would have read the message very clearly that space science is not just one branch of science. If you aspire to do something in this branch of space science, you need to be very, very clear in your fundamentals. Physics is associated, mathematics is associated. Somebody was asking, like, how do you measure the distance between stars? So there is a branch called as astrometry, which basically deals with physics and mathematics combined. You need to have an understanding of chemistry. You need to have an understanding of biology. So basically, understanding of pure sciences is what is required to be a space scientist. I see a lot of questions like, how do I become a space scientist? So the most important thing is that space science is a multidisciplinary branch of science. It is not just a standalone branch of science. So if you really want to pursue space science, Make sure you learn all the branches of science with equal emphasis and importance, so that it would become very easy for you to integrate well in this branch of science. And there is so much of opportunities. There are opportunities not just in the domain of space organizations, but there are lots of independent agencies who work to enrich the quality of activities in space. And whatever you and me are doing today, even this online virtual mode, is all thanks to space science. So space is the future, and definitely you, being passionate learners, start thinking about it, pursue more. And this 1 hour session is just to give you an insight about it. This cannot be a conclusive answer for all your queries, but definitely this can be the beginning of a thought process, or it can trigger a lot of thinking into you. Start reading more, start researching more. And when I say researching more, there are lots of data which are authentic and not authentic. So you need to have an understanding of how do you validate the data also, because some questions are all, based on certain information what they get from the net also. So try to validate the data on whatever you are reading. So that skill also you need to develop, and learn one thing at a time. So, sir, thank you once again. I have no words to share my gratitude for sparing so much time with us. Now I hand it over back to Shilpa.
Thank you, ma'am. With that, we come to the conclusion of today's session on astronomy from space. So let us know how you like the program. Like, comment, share, and follow us on Facebook, or given your review in the Vssf Kochi Facebook page. As ma'am said, we will be looking for the questions, your queries in the chat box. You could post it in there. As time permits, we will get to you back according with the answers. And once again, a reminder that the Spot 100 finals has been postponed from 24th of Feb to the 5th of March. You will be getting notifications, emails, and messages. So you could also refer our website regarding the same. The date has been changed from 24th of Feb to 5th of March. So with that, we come to the end of the session, and your next topic is medical science. It will be tomorrow from time 6 p.m. to 7 p.m. With that, we conclude. Thank you.